Aston Martin's 2026 recovery depends entirely on one filming day at the Hungaroring with reserve driver Jak Crawford. That single session had to validate Honda's new Spec 2 internal combustion engine before its Zandvoort debut on August 23. If that limited running missed drivability flaws in the redesigned pre-chamber, the team risks wasting their best development lever. The warning to Honda concerns the brutal reality of an ICE-only upgrade targeting faster combustion through revised lubrication. Any mismatch between factory targets and track reality could strand them at the back of the championship. Nobody can fully resolve this tension until cars actually hit the asphalt in the Netherlands next week. Did those few Hungaroring laps provide enough data to tame an engine with significantly changed combustion characteristics? Shintaro Orihara explicitly warned that cornering behavior would shift alongside the new power delivery profile. Independent estimates suggest a gain of 20 to 30 horsepower, but those numbers remain unconfirmed speculation. What happens if real-world drivability penalties eat up that theoretical advantage before the race ends? Orihara stated via Sports, Yahoo, that they focus on making combustion faster above all else. He knows it, we know it, rivals are watching. That admission confirms the engineering priority while highlighting the narrowness of the Zandvoort solution. This is not a holistic power unit overhaul addressing the massive electrical variance defining 2026 regulations. It is a surgical strike on the internal combustion side alone. Can such a targeted fix win against midfield rivals with stable hybrid platforms? The true danger lives in what Orihara told Motorsport, about cornering phase changes. Straight-line speed means nothing if drivers lose confidence mid-corner managing alien throttle response. Drivability is fragile, calibration takes time, data remains scarce. The filming day was mileage capped by FIA regulations, constraining the sample size for understanding new behavior. Honda confirmed hitting internal targets qualitatively, but factory confidence does not guarantee race-ready harmony. The gap between achieving a combustion target and extracting usable performance remains the open question heading into Zandvoort. The specific mission at the Hungaroring was never about setting lap times or chasing outright pace. Jak Crawford's sole objective behind the wheel was gathering drivability data for an engine that Honda knows will behave differently than anything Aston Martin has raced this season. This distinction matters because a filming day is fundamentally different from a test session, even if both involve running an F1 car on track. The FIA caps mileage strictly for promotional purposes, meaning every kilometer had to serve multiple validation goals simultaneously. There was no luxury of iterative setup changes or extended long-run simulations. Crawford had to extract meaningful feedback on throttle response and torque delivery within a tightly constrained operational window. Why assign this critical task to a reserve driver instead of Fernando Alonso or Lance Stroll? The answer lies in risk management as much as logistics. Testing an unproven combustion concept carries inherent mechanical uncertainty. Putting the primary race drivers in the car before Zandvoort would have exposed championship points to unnecessary jeopardy if reliability issues emerged during those early shakedown laps. Crawford provided a controlled variable, allowing engineers to isolate engine behavior without the compounding pressure of race weekend preparation. His feedback becomes the baseline reference point that Alonso and Stroll will build upon when they first experience the Spec 2 unit in competitive conditions. Orihara acknowledged this reality directly via Motorsport, stating they will probably need more work to improve drivability again after introduction. He added that now they know how to do it, suggesting the Hungaroring session successfully identified the specific calibration challenges ahead, but knowing the path forward is not the same as having already walked it. The gap between diagnostic clarity and competitive execution remains substantial, especially with only days separating the filming day from Zandvoort's first practice session. Engineers must translate Crawford's subjective impressions into precise software mappings before the car hits Dutch asphalt. Data collection was narrow, feedback loops were compressed, margins stayed thin. Every sensor reading from that Hungaroring session now carries disproportionate weight in pre-Zandvoort preparation. Without comparable baseline runs from other teams using similar ICE-only upgrades, Aston Martin lacks external benchmarking opportunities. They are essentially calibrating in isolation, trusting that their internal models accurately predict how the redesigned pre-chamber and altered piston geometry will interact with real-world aerodynamic loads. Factory dyno testing confirmed target achievement, but dynos cannot replicate the unique combination of Zandvoort's banking, wind patterns, and surface temperature variations. So where does that leave the team heading into the Dutch Grand Prix weekend? The filming day answered some questions while inevitably raising others. It confirmed the engine runs reliably enough for limited mileage and provided initial drivability parameters. But it could not validate whether those parameters translate to competitive advantage under race conditions. The warning embedded in this entire process is that validation remains incomplete by design. Honda achieved their combustion targets, yes. Yet achieving a target and delivering usable performance are separated by the very drivability relearning curve Orihara himself flagged as necessary post-introduction. That unresolved tension defines everything about Zandvoort's significance for Aston Martin's 2026 trajectory. Picture this for a second. You are trying to tune a grand piano while someone else is simultaneously playing a synthesizer at full volume next to it. That is essentially what Honda is attempting with this Spec 2 update, where they have completely rewritten the mechanical melody of the internal combustion engine while leaving the electrical accompaniment entirely untouched. Orihara confirmed via Sports. Calm that the team focuses exclusively on improving engine performance to make combustion faster, describing the specific method as a secret he could only disclose partially. The physical changes are substantial, involving a redesigned pre-chamber to accelerate flame propagation, an altered piston shape to optimize compression, and revised lubrication systems aimed solely at reducing internal friction. These are fundamental mechanical alterations that change how fuel burns inside the cylinder, yet the hybrid energy deployment side of the power unit remains exactly as it was before this upgrade landed. This asymmetry creates a unique engineering challenge that defines the Zandvoort risk profile. In previous regulation eras, manufacturers often balanced ICE and hybrid development in parallel, smoothing out integration issues through simultaneous calibration. But 2026 power units feature a significantly larger electrical component than their predecessors, making the interaction between mechanical and electrical power delivery more sensitive than ever before. By updating only one half of that equation, Honda has guaranteed that the existing hybrid mapping must now accommodate a fundamentally different torque curve from the engine. The MGUK output hasn't changed, but the way it supplements mechanical power now has. Drivers will feel this discontinuity most acutely during traction zones where both systems overlap, precisely where drivability matters most for lap time consistency. Combustion speed increased, friction dropped, hybrid stayed static. This deliberate imbalance means any horsepower gain comes with a tax paid in calibration complexity. Orihara's partial disclosure about the secret nature of these changes suggests Honda recognizes the competitive sensitivity of their approach, but also hints at the fragility of the solution. If the faster combustion profile doesn't harmonize perfectly with unchanged electrical deployment, the theoretical 20 to 30 horsepower estimated by independent outlets could evaporate in throttle lag or unpredictable power surges mid-corner. The warning to Honda isn't just about whether the engine makes more power, it's about whether that power arrives predictably enough for drivers to trust it through Zandvoort's high-speed sequences. What happens when mechanical ambition outpaces electrical harmony? The answer determines whether this upgrade propels Aston Martin forward or forces them into another cycle of reactive troubleshooting, Orihara stated via Motorsport. Calm, that introducing the Spec 2 engine will change combustion characteristics significantly, directly affecting car behavior in the cornering phase as well. That admission confirms the team expects behavioral shifts beyond simple straight-line acceleration gains. Cornering phase impact implies the engine's transient response differs from its predecessor, requiring drivers to relearn throttle application points and brake release timing simultaneously. This isn't merely bolting on extra horsepower, it's recalibrating the entire driver-car interface around a new mechanical reality while the electrical system operates on legacy assumptions. The decision to leave the hybrid side untouched likely reflects resource prioritization rather than technical satisfaction. GP fans reported Honda maxed out budget commitments for this update, suggesting the ICE-only scope was a strategic choice born of finite development capacity. Concentrating resources on combustion efficiency may yield greater peak returns than spreading effort across both systems, but it also concentrates risk. If the mechanical changes fail to integrate cleanly with existing hybrid maps, there is no corresponding electrical adjustment available to compensate. The asymmetry is intentional, but intentionality doesn't guarantee successful execution under race conditions. Remember how this all started, with the stark reality that if the Hungaroring filming day missed drivability flaws, Aston Martin risks wasting their best development lever for the entire 2026 season. That opening stake is no longer theoretical, it is now the defining constraint of Orihara's own technical assessment regarding cornering behavior. He explicitly warned via Motorsport. Calm that when they introduce the Spec 2 engine, the combustion characteristics will change significantly, which means engine behavior will be changed in the cornering phase as well. This is not a peripheral side effect, it is a fundamental alteration to how the car responds to driver inputs during the most critical part of any lap at Zandvoort. The warning has materialized into an engineering mandate that demands immediate attention before the first practice session even begins. This fresh drivability development curve contradicts any expectation of an instant, risk-free gain from the new power unit. Drivers cannot simply carry over their existing muscle memory or throttle maps from previous races. Every apex speed, every traction zone application, and every gear shift point must be revalidated against an engine that breathes differently through the mid-range. Calibration work intensifies, simulation models update, driver feedback loops restart. The team essentially faces a second pre-season testing period compressed into a single race weekend, with championship points hanging in the balance. There is no gradual rollout strategy available when you are already near the back of the constructor standings and desperately need performance. Orihara's confidence in hitting factory targets does not eliminate this on-track uncertainty. He stated via Sports.com that he is confident in what the HRC Sakura factory guys achieved, but factory achievement and track adaptation are separate milestones. The cornering phase changes mean that even if peak horsepower matches the optimistic 30 BP estimates, usable horsepower may lag behind until drivers and engineers synchronize their understanding of the new torque delivery. Zandvoort's unique combination of banking and low-speed chicanes amplifies this challenge, making it perhaps the worst possible venue for betting in a fundamentally altered combustion profile. The circuit punishes hesitation and rewards precision, neither of which comes naturally to a power unit still learning its own limits. Though what does this recalibration demand from the team right now? It requires accepting that Zandvoort results may not fully reflect the engine's ultimate potential. Early laps will prioritize data gathering over outright pace. Setup compromises may mask true performance while protecting drivability. The fresh development curve Orihara flagged ensures that any competitive gain emerges gradually rather than arriving as a sudden leap up the timing sheets. This reality tempers expectations without diminishing the upgrade's importance. It simply reframes success as process completion rather than immediate podium contention. The warning embedded in those cornering phase changes is that patience, not just power, will determine whether the Spec 2 engine ultimately delivers on its promise or becomes another cautionary tale of ambitious engineering meeting unforgiving track conditions.